Good morning, students, and welcome to the first video of chapter Simple Machines. In this video, we will cover the following topics. First, we will talk about a simple machine. What is a simple machine? We will discuss some uses of simple machines in our day-to-day life. Then, we will talk about some terms related to simple machine. And in the last section, we will talk about the functions of simple machines. First, let us know, children, what is a simple machine. Simple machine is a device that helps us to do our work easily by applying less force and spending less energy. We come across many simple machines in our daily life, such as lever, pulley, inclined plane, screw, wedge, etc. And these are used for many purposes in our daily life. Now, a question may come in our mind: why do we need these machines? We will discuss some examples from our daily life through which we can understand how these machines are helpful to us. You would have observed that it is easier to open the cap of a bottle with a bottle opener than with our hands. Bottle opener is a simple machine that makes the work easier for us. Similarly, if we try to lift a heavy box with other hand, we will not be able to do so. We need a trolley to lift the box easily. Try to open a tight nut with your fingers. It is a difficult job. You will not be able to succeed. But the same activity, when done with the spanner, makes the task easier for us. All these examples conclude that machines not only make our work easier, but also reduce our effort. Okay, children. Now let's talk about some terms that are related to simple machines. The first one is called effort. Effort is the force applied on a machine to do some work. It will be denoted by E. In the figure, you can all see E represents effort. The next one is load. What is load? Load is the force applied by a machine on an object on which the work is to be done. Load will be denoted by L. Fulcrum. A machine can turn about fixed point called fulcrum. So fulcrum is the fixed point and it will be denoted by F. Let's talk about the principle of machine. Machine cannot work on its own. As all of you know that some energy is needed for the work to be done. This energy has to be supplied so that the machine can work properly. The energy supplied to a machine is called, children, input energy. Therefore, the work done by this energy will be called input work. The useful work done by machine is called the output work. Now, ideally, the output work should be equal to input work. But practically, this is not true. In actual practice, the output work is less than the input work. What does the efficiency of machine means? Children, efficiency, it's the ratio of useful work done by a machine on the load to the work done on the machine by the effort. So according to the formula, efficiency is output work by input work. In the terms of percentage, we can express efficiency as the output work by input work multiply by 100. So that's the percentage. The efficiency of machine can be anywhere between 1% and 100%. So it can be 20%, 30%, 80%. Now a machine that has efficiency 100% or has the value 1, that is called ideal machine. In an ideal machine, no part of the work is wasted. But actually this is not true. It is not possible. Practically, some part of the work done by a machine will always be wasted. It will be lost in overcoming the friction, because without friction, all of you know, a machine cannot work. This is the reason we call a machine as actual machine and not ideal machine. The efficiency of a machine is always less than 100%. For example, it can be 70%, it can be 80%. So if it is 70%, remaining 30% will be lost in overcoming friction. And if it is 80%, 20% will be lost in overcoming friction. Children, let's talk about mechanical advantage now. Mechanical advantage is the ratio of load to effort. It is expressed by the formula load divided by effort. Now mechanical advantage can be equal to 1, less than 1 and greater than 1. How does that occur? If load is greater than the effort, then mechanical advantage will be greater than 1. If in case effort is greater than load, then mechanical advantage will be less than 1. And if in case load and effort are equal, the mechanical advantage is equal to 1. Talking about the last topic for today, functions of machine. The first function of machine is that machine acts as a multiplier of force. This means that it helps us lifting heavy load by applying less effort. I will be giving an example to make the concept clear. To change the tire of the car, we need screw jack. We cannot do it without using a screw jack. So in this case, the effort is less than the load. Second function is a machine can change the direction of the effort to a convenient direction. Let's understand again with the help of an example. If we have to lift a bucket of water from a well, it's a difficult job. Why? Because the force has to be applied in upward direction, that is against gravity. But if we use a pulley to do the same work, it becomes easier for us. Now the reason is that in the case of pulley, we apply force in a downward direction, that is towards the direction of gravity. So machine is changing the direction of the force applied. Another function of simple machine is the machine can apply force at a convenient point. Let's understand with an example. As children, all of you know it's difficult to tighten the screw with our hands. We cannot do it. But it can easily be done with the help of an instrument called screwdriver. In a screwdriver, to apply force at the handle, the force acts on the head of the screw and then moves the screw inside the table. With this, we come to the end of our first video session. I hope you enjoyed the lesson and the concepts are clear to you. Thank you, children, and have a nice day.